What if I told you that right now, at this exact moment, we're receiving the first light ever detected from an object that entered our solar system 3 months ago, and that light is defying every law of physics we understand, showing spectral lines that shouldn't exist, wavelengths that metals can't produce, and a signature that matches nothing in our periodic table? Not a comet, not an asteroid, not like anything we've seen before. The third interstellar object ever detected entering our solar system, designated 3I Atlas, discovered October 8, 2025, by the Atlas Survey System in Hawaii. Trajectory confirmed within hours. Origin, extrasolar. Coming from the direction of Vega, 25 light-years away. Traveling at 87 kilometers per second relative to the Sun. Hyperbolic orbit. Not bound to our solar system, just passing through. Like Oumuamua in 2017. Like Borisov in 2019. Interstellar visitors. Messengers from other star systems. Brief tourists in our cosmic neighborhood. Except this one is different. Fundamentally different. Impossibly different. Because the light is wrong. November 15, 2025. Aero 342 UTC. First photons from 3I Atlas reached Earth-based spectrographs, multiple telescopes, Keck Observatory in Hawaii, Very Large Telescope in Chile, Gemini Observatory, all observing simultaneously, all recording spectra, all seeing the same impossible thing. Dr. Michelle Bannister at University of Canterbury, New Zealand, was first to notice. The spectrum makes no sense. I've been analyzing comets and asteroids for 15 years. I know what spectra should look like. This isn't it. I don't know what this is. Normal objects, asteroids, comets, planets, moons, reflect sunlight. Absorption lines tell us composition. Specific wavelengths absorbed by specific elements. Iron absorbs at 527 nanometers. Magnesium at 518 nanometers. Silicon at multiple wavelengths. Standard spectroscopy. Taught in undergraduate physics. Simple, reliable, universal. I-Atlas shows absorption lines at wavelengths where nothing absorbs. 437.8 nanometers. No element in the periodic table has transition at that wavelength. 491.2 nanometers. Nothing. 523.6 nanometers. Nothing. 558.1 nanometers. Nothing. 15 distinct absorption lines. None matching any known element. None matching any known molecule. None matching any known mineral or compound or alloy or anything in our spectroscopic databases. Either our 200 years of spectroscopy is completely wrong, Dr. Bannister said, or this object is made of matter we've never encountered. Elements that don't exist on Earth. Chemistry that doesn't exist in our solar system. Materials that shouldn't exist according to nuclear physics. Because the periodic table is universal. Elements form the same way everywhere. Same quantum mechanics. Same atomic structure. Same spectral lines. Except this object says that's wrong. But it gets stranger. The object is also emitting light. Not just reflecting, emitting. Faintly. In infrared. Thermal emission from heating by sun is expected. All objects do that. But 3I Atlas is emitting 40% more infrared than its temperature allows. Energy coming from somewhere internal. Radioactive decay? Chemical reactions? Something else? Unknown, and the polarization is wrong. Light reflecting off surfaces gets polarized. Specific patterns depending on surface properties. Rough surfaces polarize differently than smooth surfaces. Ice differently than rock. We measure polarization. Determine surface characteristics. Standard technique. Dot 3I Atlas's reflected light shows polarization pattern never observed before. Negative polarization at phase angles where it should be positive. Circular polarization where it should be linear. As if the object is made of material that interacts with light in ways we've never seen. Optical properties that don't match any known substance. 3 independent, impossible observations, Dr. Alan Fitzsimmons at Queen's University Belfast summarized. impossible spectral lines, impossible infrared excess, impossible polarization. Anyone would be remarkable. All three suggests we're not dealing with normal matter. Either the object is made of exotic materials, maybe from a completely different stellar environment, or something more radical, something that challenges our understanding of physics itself. The scientific community is racing to observe before it's too late. 3I Atlas is moving fast, already past Mars' orbit, headed toward Jupiter. We'll reach perihelion, closest approach to Sun, on December 3, 2025. Then swings back outward. Past Earth orbit by January, past Mars by February, gone from observable range by March. We have 4 months. 4 months to solve the mystery. 4 months to understand what this object is. 4 months before it vanishes into interstellar space forever. If you want to fall asleep exploring the impossible object from another star system, understanding why its light breaks physics, learning what it might be made of, discovering what this means about the universe beyond our solar system, and realizing that interstellar space might contain matter and chemistry we never imagined, subscribe right now. Every week we explore cosmic mysteries that shatter what we think we know. This is 3I Atlas, the visitor that brought impossible light, the object that shouldn't exist. Let's investigate why photons from 25 light-years away are telling us our physics is incomplete. October 8, 2025, 11:37 UTC. Atlas MLO, Asteroid Terrestrial Impact Last Alert System, Mauna Loa Observatory, captured routine images of the sky. 4 exposures, 30 seconds each, separated by 10 minutes, covering 100 square degrees, looking for moving objects, asteroids, comets, near-Earth objects that might threaten Earth. Automated software compared images, identified objects that moved between frames, flagged 47 candidates, mostly known asteroids. 3 were new, requiring follow-up. Standard night. Nothing unusual expected. Candidate number 23 was flagged yellow. Unusual motion. Faster than typical asteroids. Trajectory looked wrong. Software calculated preliminary orbit. Result: hyperbolic. Eccentricity: 1. That meant unbound, not orbiting Sun. Passing through. Interstellar. Dr. Larry Deneau at University of Hawaii received alert. Automated email. Atlas detected possible interstellar object. Requires immediate confirmation. He'd seen false alarms before. Asteroids on Earth-crossing orbits sometimes appear hyperbolic before orbit is refined. Need more data, more observations. Usually resolved as normal asteroids, but protocol is protocol. Alert the network. Get confirmations. Within 20 minutes, 3 other observatories were observing. Pan-STARRS in Hawaii, Catalina Sky Survey in Arizona, Spacewatch in Arizona, all confirming object real. Moving fast. Trajectory unusual. Dr. Deneau calculated velocity, 87.3 kilometers per second relative to Sun. That's 194,000 miles per hour. Extremely fast. Faster than any bound solar system object. Definitely interstellar. 3rd confirmed interstellar object ever detected. After Oumuamua, 2017, and Borisov, 2019, designation assigned 3I 2025 U1 Atlas. 3I means 3rd interstellar object. 2025 U1 means discovered in second half of October 2025, first object that half month. Atlas, credits Discovery Survey. Excitement was immediate but measured. Interstellar objects are rare, precious opportunities, but past experience taught caution. Oumuamua was bizarre. Elongated shape, non-gravitational acceleration, no coma, weird trajectory. Generated enormous speculation. Aliens? Solar sail? Natural explanation eventually emerged. Probably. Borisov was normal comet, unremarkable except for origin. Water ice, carbon dioxide, cyanide. Typical comet composition. Just from another star system, What would 3I Atlas be? Exciting, but probably normal. Probably asteroid or comet from another stellar system. Interesting, but not revolutionary. Study it. Measure composition. Compare to solar system objects. Learn about other planetary systems. Good science, important observations, but likely not paradigm-shifting. That expectation lasted 5 weeks, until spectroscopy began, until the impossible photons arrived. November 15, 2025. 3I Atlas was now magnitude 19.2, bright enough for spectroscopy with large telescopes. Still faint, requiring 8 to 10 meter class instruments, but observable. Multiple observatories requested time, allocated emergency observations. This was important. Rare opportunity. Interstellar visitor. Limited time. Observe now or lose it forever. Dr. Michelle Bannister received telescope time on Gemini North. 8.1 meter mirror. Excellent spectrograph. November 15-16 allocated. 2 nights. Goal, measure reflected light spectrum. Determine composition. Compared to known asteroids and comets. Characterize the visitor. First spectrum. November 15th, 0342. UTC integration time. 45 minutes. Object faint. Need long exposure. Spectrum emerges slowly. Photons accumulating. Software processing in real time. Building spectral energy distribution. Wavelength versus intensity. Bannister watched screen, expecting typical asteroid spectrum, relatively flat. Some absorption features from minerals. Maybe pyroxene absorption at 900-1000 nanometers. Maybe olivine features at 1050 nanometers. Standard asteroid minerals. Or maybe comet spectrum. Bluer. Icy. Possible emission from sublimating volatiles. What appeared was neither. The spectrum was strange immediately. Slope was unusual, steeper than asteroids, but wrong color for comet. And features appeared. Sharp absorption lines, multiple, at wavelengths that looked wrong. That can't be right, Bannister said to colleague. Check calibration. Something's wrong with the wavelength solution. Calibration checked. Wavelength solution verified using atmospheric absorption lines and arc lamp calibration frames. Accurate to 0.1 nanometers. No errors detected. Spectrum was real. She pulled up spectral databases. Compared to known minerals, pyroxene, no match. Olivine, no match. Water ice, no match. Methane ice, no match. CO2 ice, no match. Iron oxides, no match. Phyllosilicates, no match. Organics, no match. Nothing matched. Absorption line at 437.8. 8 nanometers. She searched atomic transition databases. No element absorbs there. Molecular databases. No molecule. Mineral databases. No mineral. The line shouldn't exist. 91.2 nanometers. Same story, no match. 503.6 nanometers. No match. 508.1 nanometers. No match. 15 distinct absorption lines. None explained by known chemistry. This is contamination, she decided. Terrestrial contamination. Atmospheric absorption we're not correcting properly. Or instrument artifact. Or software error. Something wrong with data reduction pipeline. But other observers were seeing the same features. Dr. Alan Fitzsimmons at Very Large. Telescope. Dr. Davide Perna at TNG. Telescopio Nazionale. Galileo. Dr. Bin Yang at ESO. All independent observations. All independent data reductions. All seeing same absorption lines at same wavelengths. Not contamination. Not artifact. Real features. From the object. November 16th. Emergency teleconference. 20 spectroscopists comparing data, sharing observations, trying to understand. Could this be known elements in unusual conditions? High pressure? High temperature? Extreme magnetic fields? All shift spectral lines slightly. Maybe these were known elements shifted. They calculated. To shift iron lines to observed wavelengths required pressure of 5 gigapascals. That's 50,000 atmospheres. Interior of Earth pressure. Not surface of asteroid. Impossible. Temperature shifts were wrong direction. Extreme temperatures broaden lines, don't shift them to completely wrong wavelengths. Magnetic fields create Zeeman splitting. Multiple closely spaced lines. Not observed. The features were single sharp lines at wrong wavelengths. Not explainable by environmental effects. These aren't artifacts. These aren't known elements in weird conditions. These are genuinely unknown spectral features, Dr. Fitzsimmons concluded. Which means either our spectroscopy is fundamentally broken, which contradicts 200 years of physics and chemistry and astronomy, or this object contains materials we've never encountered. Elements not in our periodic table, or compounds with electronic structures we don't understand, or something completely outside our experience. November 18, 2025. Dr. Karen Oberg at Harvard-Smithsonian Center for Astrophysics, astrochemistry expert, analyzed the implications. If spectral lines were real, if they truly represented atomic or molecular transitions, what did that mean? Spectroscopy works because of quantum mechanics. Electrons in atoms occupy specific energy levels. Transitions between levels absorb or emit photons of specific energies. Energy corresponds to wavelength. Each element has unique pattern, unique fingerprint, universal, the same on Earth as in distant galaxies, because quantum mechanics is universal. Same everywhere, unless it's not. Unless quantum mechanics is different in different environments, or unless there are elements that don't exist on Earth. Elements with atomic numbers above 118, super-heavy elements, island of stability predicted by nuclear physics, elements that might be stable beyond uranium, beyond the known periodic table. Island of stability theory predicts elements around atomic number 126 might be relatively stable, Oberg explained. Half-lives of years instead of microseconds. If such elements exist, they'd have electron configurations we've never observed. Spectral lines at unpredicted wavelengths. Could 3I Atlas contain super-heavy elements? Elements that formed in neutron star mergers, or in supernovae, or in exotic stellar environments, then got incorporated into planetary system, then got ejected as interstellar object? Dr. Witold Nazarewicz at Michigan State University, nuclear theory expert, calculated. Super-heavy elements would require extraordinary synthesis conditions. Multiple neutron captures, rapid process. Our process nucleosynthesis happens in neutron star mergers, creates elements up to uranium and beyond. Theoretically could produce elements to Ze-126 or higher, but abundances would be tiny. Parts per trillion, not enough to dominate a spectrum. Unless, he continued, the object formed in debris of neutron star merger. Direct condensation from our process ejecta. Then super-heavy element abundance could be percent level, enough to see spectroscopically. That would make 3I Atlas extraordinary. Piece of neutron star merger debris, wandering interstellar space for millions of years. Now passing through our solar system, carrying elements that don't exist naturally on Earth. But super-heavy elements were speculative, never detected, only theoretical. Using them to explain observations was explaining unknown with unknown. Not satisfying, not scientific unless testable, alternative, exotic molecules. Dr. Brett McGuire at MIT, molecular spectroscopy expert, proposed complex organic molecules. Polycyclic aromatic hydrocarbons, long carbon chains, fullerenes. Complex organics can have electronic transitions at arbitrary wavelengths depending on structure. Maybe 3I Atlas is coated in organic material we've never synthesized, formed in dense molecular cloud, or in protoplanetary disk with unusual chemistry. Molecules that don't exist in our solar system but are stable under right conditions. He searched molecular databases, thousands of known molecules, millions of transitions cataloged. None matched, but that didn't mean molecules didn't exist, just meant we hadn't made them in lab, hadn't measured their spectra. Universe is bigger than our laboratory experience. Maybe 3I Atlas was teaching us new chemistry. November 22nd, 2025. Dr. Jennifer Bergner at UC Berkeley proposed radical alternative. What if the absorption isn't from the object's surface? What if it's from material surrounding the object? Atmosphere? Coma? If 3I Atlas is outgassing unusual volatiles, maybe noble gas compounds that are unstable at Earth temperatures, but stable at interstellar space temperatures, they'd create coma, absorb light, produce spectral features, features from molecules that dissociate before we can study them in lab. Noble gas compounds, xenon hexafluoride, krypton difluoride, argon fluorohydride, all unstable at room temperature, exist only at low temperatures or high pressures. If 3I Atlas formed in extreme environment, cold molecular cloud, high-pressure planetary interior, it might contain trapped noble gas compounds, now sublimating slowly, creating coma of exotic chemistry. Chemistry we've never observed because we can't reproduce the conditions. Testable prediction. Coma should be detectable. Spatially extended. Should see absorption lines strengthening away from nucleus. If absorption is from surface, intensity is uniform. If from coma, intensity varies with distance from center. High-resolution imaging attempted. Hubble Space Telescope. November 24-25. Observations requested. Approved as director's discretionary time. Target of opportunity. Image the object. Look for coma. Measure spatial extent of absorption. Results. No detectable coma. Object appears point source. No extended structure. Absorption is from object itself, not surrounding gas. Back to materials problem. The object's surface contains unknown substances. November 26, 2025. While spectroscopists puzzled over visible light, infrared astronomers noticed something else. Dr. Carrie Lisa at Johns Hopkins Applied Physics Laboratory observed 3I Atlas with James Webb Space Telescope. Mid-infrared, 5 to 28 micron wavelength range. Goal, measure thermal emission. Determine temperature. Calculate size. Standard measurements, Webb's MIRI instrument observed for 6 hours. Excellent signal to noise. Clear thermal emission detected. Temperature determined from blackbody fit. 110, 104 Kelvin. That's 90.2 C. Reasonable for object at 2.4 AU from Sun. Matches expected equilibrium temperature. But flux was wrong. The object was emitting 40% more infrared than expected from solar heating alone. Energy balance didn't work. Input absorbed sunlight. Output emitted infrared. Violation of thermodynamics unless something was supplying extra energy. This is unphysical, Lisa said. Object is radiating more energy than it receives from sun. Energy is coming from somewhere internal. Radioactive decay? All asteroids have some radioactivity. Potassium-40, thorium, uranium. But that produces microwatts per kilogram. Not enough to explain 40% excess. Need something much more powerful. Cometary activity. Sublimating ices absorb energy. Latent heat of sublimation. That cools surface. Should reduce thermal emission, not increase it. Wrong direction. Chemical reactions. Exothermic reactions release energy. But what reactions? Need continuous energy output for weeks. Need reactants that don't deplete. And no coma detected. No outgassing. If chemical reactions happening, products aren't escaping. Radioactive decay of short-lived isotopes, aluminum-26, iron-60, nickel-63. Isotopes with half-lives of years to millions of years. If 3I Atlas contained these, they'd produce heat. But these isotopes are rare, produced in supernovae, or stellar nucleosynthesis, would need high abundance to produce observed excess. Unless, Lisa realized, the object formed very recently, within 10 million years, before short-lived isotopes decayed. That would require it ejected from young planetary system. system still containing supernova debris, or system that just experienced supernova nearby, enriching local environment with fresh radioactive isotopes, or something more exotic. Crystallization energy. If object's interior is transitioning from amorphous to crystalline structure, that releases energy, observed in cometary nuclei, but requires icy material. And 3I Atlas doesn't show water-ice spectral features. Different chemistry, maybe crystallization of unusual compounds. Organic ices, noble gas hydrates, released energy as they transform. Dr. Emmanuel Lelouch at Paris Observatory modeled energy balance. To produce 40% excess at observed temperature requires internal heat source of 0.3 watts per square meter of surface. For estimated size of 500 meters diameter, that's 240 kilowatts total power. Sustained. Continuously. That's substantial. Equivalent to radioactive decay of several kilograms of plutonium-238, or crystallization of several thousand kilograms of material per day, or something we haven't thought of. The infrared excess was second impossibility. First was spectral lines. Now was energy excess. Two independent observations, both inconsistent with normal physics. Pattern emerging. This object was fundamentally unusual. December 1st, 2025, Dr. Stefano Bagnulo at Armagh Observatory, Northern Ireland, polarimetry expert, observed 3I Atlas using 4S2 instrument at Very Large Telescope, measuring linear and circular polarization, determining surface properties, optical characteristics. Polarimetry works because light scattering depends on surface structure. Smooth surfaces produce strong polarization. Rough surfaces produce weak polarization. Spherical particles polarize differently than elongated particles. By measuring polarization at different phase angles, different viewing geometries, you determine surface properties. Grain size, shape distribution, surface roughness, composition, standard technique. Used on asteroids for decades. Reliable, predictive, well understood. 4S2 data showed polarization of 8.3% at phase angle of 67 degrees. Linear polarization. Perpendicular to scattering plane. That's normal. Expected. Then Bagnulo measured different phase angles. 45 there. Polarization 6.1%. Still normal. 30 dim. Polarization 3.2%. Getting unusual. 15 image polarization 1.4%. Negative. Impossible. Negative polarization means light is polarized parallel to scattering plane, Bagnulo explained. That only happens in very specific circumstances. Multiple scattering, coherent backscattering, or exotic optical properties. But at 15-degree phase angle, we should see positive polarization. Always. For any known material. This is wrong. He measured circular polarization, light wave rotating as it travels. Right-hand circular or left-hand circular? Natural surfaces produce minimal circular polarization, maybe 0.1, 0.2%. Mostly linear 3I Atlas showed 3.7% circular polarization. Right-hand? That's enormous. 20 times higher than any asteroid or comet. Only seen in structured surfaces, biomolecules, chiral materials, asymmetric crystals, or multiple scattering in optically active media. This suggests surface material with intrinsic chirality, Bagnulo said. Like biological molecules, amino acids, sugars, all have handedness, preferentially left hand or right hand, produce circular polarization when illuminated. But 3.7% is much higher than organics typically produce. Unless surface is covered in pure chiral compounds, all same-handedness. That's unlikely naturally. Alternative, structured surface at wavelength scale. Surface texture matching wavelength of light. Creates diffraction effects. Coherent scattering. Could produce both negative linear polarization and strong circular polarization, but requires extremely regular structure. Periodic, like diffraction grating, or photonic crystal. Natural formation of such structure is implausible. Unless the object isn't natural, Bagnullo said carefully. Unless it's manufactured, artificial surface, designed optical properties, like Oumuamua speculation. But this is more extreme. More evidence of non-natural properties. I'm not saying it's alien. I'm saying the optical properties don't match any natural material we know. The community recoiled. We're not doing aliens again, Dr. Fitzsimmons stated firmly. Oumuamua taught us that lesson. Natural explanations exist. We just need to find them. Jumping to artificial hypothesis is premature, unscientific, destroys credibility. But privately, conversations happened. What if it is artificial? What would we do? How would we know? Do we have protocols? No good answers, just discomfort. Hope it wasn't aliens, because dealing with that would be beyond astronomy's scope, beyond science's ability to handle with current frameworks. December 5, 2025. While observers puzzled over impossible properties, Dr. Fatih Namouni at Côte d'Azur Observatory, France, orbital dynamics expert, traced the object's history. Where did 3I Atlas come from? What stellar system ejected it? When? Trajectory was well determined. Dozens of observations, precise astrometry, orbit calculated to high accuracy, current parameters. Velocity, 87.3 kilometers, relative to Sun. Eccentricity, 2.47, highly hyperbolic. Inclination, 87.22, nearly perpendicular to ecliptic. Incoming direction, RA 279 degree. Deck plus 40 gravity, pointing toward Vega, Namouni integrated backwards. Reversing trajectory. Where was object 10,000 years ago? 100,000? 1 million? Tracing path through galaxy. Accounting for galactic rotation, stellar motions, gravitational perturbations from passing stars. The calculation was complex. Galaxy isn't static. Stars orbit galactic center at different rates. Sun orbits with period of 225 million years. Vega orbits differently. Objects in interstellar space follow ballistic trajectories, modified by gravity of stars they pass. Like pinball, bouncing through galaxy, Namouni reconstructed trajectory. 3I Atlas passed within 1 light-year of Vega approximately 300,000 years ago. Velocity relative to Vega was 15 km/s. That's fast for ejection from planetary system, but possible if ejected by close encounter with giant planet or by stellar companion. Vega is single star now, but might have had companion, brown dwarf, or massive planet, something that could perturb objects to high velocities. But Vega is young, only 455 million years old. Planetary system would be young, still forming, ejecting large numbers of planetesimals. Normal process. Our solar system ejected billions of objects during planetary migration. Most went to Oort cloud. Some escaped to interstellar space. Same process likely happened at Vega. I Atlas might be planetesimal from Vega system, Namouni concluded. Ejected during planet formation. Traveled 25 light-years over 300,000 years. Now passing through our solar system. Carrying samples of Vega system composition, chemistry from different stellar environment. That explains unusual spectral features, different stellar neighborhood, different initial composition, different chemistry. Not impossible, just unfamiliar. That would make 3I Atlas scientific treasure. Direct sample from another planetary system. Material we could analyze. Compare to solar system. Learn how planet formation varies with stellar environment. Vega is A-type star, hotter than Sun. Different radiation environment, different chemical processes. Planets forming there would have different composition. This object might exemplify that difference. December 10th. Namouni published trajectory analysis. Paper titled 3I Atlas, a planetesimal from the Vega system, explaining origin, predicting composition differences. Arguing for intensive observation campaign before object escapes. The community rallied. every available telescope, every wavelength, every technique. Observe 3i Atlas, maximum science return, before it's gone forever. But the observations kept producing impossible results. The spectral lines remained unexplained. The infrared excess continued. The polarization defied optics. Natural explanation from Vega system chemistry should solve mysteries, but didn't. The object remained impossible. December 15th, 2025. Dr. Andrew Rivkin at Johns Hopkins Applied Physics Laboratory proposed audacious plan. Sample return mission. Go to 3i Atlas, collect material. Return to Earth, analyze in laboratory. Solve mysteries definitively. The timeline was brutal. Object approaching perihelion. December 28th. Closest approach to Sun. 1.3 AU. Then departing. Moving away. Every day made mission harder. More fuel needed. Longer flight time. Need to launch soon. Very soon, within months. Or miss opportunity forever. This is impractical. NASA's Planetary Science Division Director responded, "Sample return missions take years to design. Spacecraft must be built, tested, integrated, launched. We can't do that in months. Impossible timeline." But private sector thought differently. SpaceX, Blue Origin, Rocket Lab, all had launch vehicles, all had rapid response capabilities. Could they do it? Launch mission to interstellar object? In months? December 18th. Elon Musk tweeted, "SpaceX can launch mission to intercept 3i Atlas. Starship Block 2, fully fueled in orbit. Enough Delta V to catch interstellar object. Sample return via Dragon capsule. Timeline, 8 months design, 4 months build. Launch March 2026. Intercept June 2026. Return December 2027. Cost, 800 nanisers. Who's paying? NASA. We don't have budget authority for unplanned 800-meter mission. Requires congressional approval. Takes years, ESA. Same constraints. Cannot commit funds without member state approval. Requires coordination. Long timeline. Then anonymous donor emerged. Cryptocurrency billionaire. Offer $1 billion for mission. Full funding. No strings. Just execute mission. Return samples. Make data public. For science. For humanity. For solving mystery. SpaceX accepted. Mission greenlit. December 20th, 2025. Project Icarus. Interstellar capture and return using Starship. Timeline, January, February 2026. Design spacecraft. Select instruments March-April 2026. Build and test hardware May 15. 2026. Launch Starship to Leo May. 16 to 20. Refuel in orbit. 7 launches. May 25, 2026. Trans 3i injection burn June 18th. 2026. Intercept 3i Atlas. Relative velocity 12 km. Hjärtstry eats. June 18th. Sample collection. Impact probe plus dust capture. June 19th. Return trajectory. Burn December 14th. 2027. Earth return December 15th. 2027. Samples in laboratory audacious. Aggressive. Maybe impossible. But theoretically feasible. Starship had required performance. SpaceX had launch cadence. Money was available. The question, could they design, build, and fly mission in 5 months? Nobody had done anything like this, ever. Normal planetary missions took decade. This was 5 months. Insane timeline, but also unique opportunity. If successful, would return first interstellar material ever collected. Material from another stellar system. From Vega, different chemistry, different elements, different physics. Worth the risk, worth the cost, worth the attempt. January 2026. Work began. Around the clock. Engineers designing spacecraft. Scientists selecting instruments. Software developers coding flight systems. Manufacturing facilities producing hardware. Unprecedented pace. Impossible schedule. but motivated by once-in-lifetime opportunity. December 28, 2025. 3I Atlas reached perihelion. Closest approach to Sun. 1.3 AU, about 195 million kilometers. Between orbits of Earth and Mars. Maximum solar heating. Maximum activity expected if object was cometary. Every telescope watched. Optical, infrared, radio, X-ray. Full electromagnetic spectrum coverage. Coordinated campaign. Continuous monitoring. Looking for changes. Activity. Outgassing. Fragmentation. Anything. At 04.17 UTC, something changed. Dr. Matthew Knight at U.S. Naval Academy was monitoring with SOHO spacecraft, Solar and Heliospheric Observatory, coronagraph images, designed to watch Sun, but also caught nearby objects. I-Atlas appeared in LASCO C3 field of view, faint dot, moving slowly relative to stars, then suddenly brightened. Over 3 minutes, brightness increased by factor of 10, then stabilized. Not fragmentation, object remained point source, not outgassing in typical sense. No extended coma appeared, just brightening. Intrinsic luminosity increased. It's not reflecting more sunlight, Knight said. The sun didn't get brighter. The object is emitting light. Intrinsic emission. Something activated. Something inside the object turned on. Spectroscopy confirmed. Emission lines appeared. Not absorption, emission. Light being produced by object itself. Wavelengths. Same as the mysterious absorption lines seen earlier. 437.8 nm, 491.2 nm, 523.6 nm, all others. But now in emission. The material isn't just absorbing these wavelengths, Dr. Bannister realized. It's fluorescent. Absorbs light at these wavelengths. Gets excited. Re-emits at same wavelengths. Like fluorescent minerals under UV light. Except we're seeing fluorescence at visible wavelengths from solar illumination. That's unusual. Very unusual. Fluorescence requires specific electronic structure. Ground state absorbs photon. Electron transitions to excited state. Electron decays back to ground state. Emits photon. Same energy. Same wavelength. Happens in some molecules. Rare in natural materials. Common in manufactured fluorescent dyes. This is biosignature, Dr. Michael Gillen at University of Liège proposed cautiously. Biological molecules fluoresce. Chlorophyll, flavins, tryptophan. Biological chemistry produces fluorescent compounds. Maybe 3I Atlas has biological material on surface. Dead organisms, or organic material from living systems. Ejected from inhabited planet, carrying biosignatures across interstellar space. The claim was inflammatory. Immediate pushback. We're not doing this, multiple astronomers objected. Not biosignatures, not from single observation, not without extraordinary evidence. Fluorescence doesn't equal biology. Lots of organic materials fluoresce. Polycyclic aromatic hydrocarbons, complex tholins, radiation-processed ices. No biology required, but the timing was suspicious. Object brightened at perihelion. Maximum solar heating. Maximum energy input. As if something temperature-dependent activated. Chemical reaction triggered by warmth? Phase transition releasing stored energy? Or, speculatively, some kind of mechanism responding to solar proximity? December 29th. The emission continued. Not fading, sustained brightness. Object was maintaining intrinsic emission for over 24 hours. Whatever process began at perihelion wasn't transient, wasn't momentary, was sustained. Continuous energy output. Dr. Carrie Lissa measured infrared flux with Webb. Infrared excess has increased. Now 80% above expected thermal emission. Object is radiating twice what it should. Energy output doubled. Something is definitely happening internally. Chemical? Physical? Radioactive? Unknown. But real, measurable, undeniable. December 30th. New spectral features appeared. Emission lines at 621.3 nanomars, 687.99 nanomar, 742.1. 1 nanometer additional wavelengths, still not matching any known elements or molecules, but pattern was emerging. Line spacing suggested electronic transitions with energy differences of U0.3 eV, 0.4 eV, 0.5 eV. Regular intervals? That meant quantized system. Electronic levels with regular spacing. This is molecular, Dr. Brett McGuire concluded. Atomic transitions don't have regular spacing. Molecular vibrations do. This might be vibrational structure superimposed on electronic transitions. Large molecule, complex, multiple vibrational modes, creating series of lines with regular spacing. But what molecule? Nothing in spectroscopic databases matched. Either molecule was uncharacterized, never studied in laboratory, or molecule was entirely new. Novel compound. Chemistry not found on Earth. January 3, 2026. Dr. Andrew Siemion at SETI Institute, Berkeley, was monitoring 3I Atlas as part of Breakthrough Listen program. Protocol: observe all interstellar objects. Look for technosignatures, radio emissions, laser pulses, anything suggesting technology. Standard procedure after Oumuamua speculation. Green Bank Telescope, 100-meter radio dish. Observing 3I Atlas, frequencies 110G THz, looking for narrow-band signals, carrier waves, modulation, anything non-natural. At 18:23 UTC, receiver detected signal, 142 GHz, hydrogen line frequency, narrow bandwidth, 0.1. 1 Hertz/16. A much narrower than natural emissions. Natural sources, pulsars, masers, plasma emissions, have broad spectra, kilohertz or megahertz bandwidth. This was 0.1 ankertin sen. Hertzitusinchen, Transetsenks, artificial narrowness, Siemion's heart raced. This was SETI's dream scenario. Narrowband radio signal from interstellar object. But also SETI's nightmare scenario. Because extraordinary claims require extraordinary evidence. And history showed most signals were interference. Human-made, satellites, aircraft, ground transmitters. Not aliens. Never aliens. Always false alarms. Check for interference, Siemion ordered. Off-source observations. Nodding. Verify signal tracks the object. Prove it's from 3I Atlas, they observed. On source, signal present. Off source, signal absent. Back on source, signal present. The signal tracked the object. Moved with it across the sky. Not ground interference, not satellite. From the object. Or from something at the object's coordinates. Signal characteristics. Frequency. 1.42 to 405752. GHz. Hydrogen line. Redshifted by 87 km/s. Bandwidth. 0.1 Hz modulation. None detected polarization. Right-hand circular. 100% flux. 0.3 Jansky's duration. Continuous. Observed for 4 hours. Still transmitting. This is carrier wave, Siemion said. Unmodulated. No information content. But narrowband. Artificial. And at hydrogen line frequency. That's universal signaling frequency. Chosen because hydrogen is most common element. Any technological civilization would know this frequency. Would search here. Would transmit here. Using this frequency is deliberate choice. He contacted Breakthrough Listen principal investigator. Emergency meeting. Alert SETI community. Alert NASA. Alert everyone. Possible technosignature from interstellar object. This was unprecedented. This was what they'd searched for. This was contact scenario, but also extreme caution required. We've had false positives before, lead investigator reminded. 2019's BLC-1 appeared to be signal from Proxima Centauri. Turned out to be radio interference. We announced carefully. Then retracted. Looked foolish. Can't do that again. Need absolute certainty before making claims. January 4th. More observations. Arecibo's replacement facility. Parcas Observatory. Effelsberg. All confirming. Signal present. Narrow band. Tracking object. At hydrogen line frequency. Multiple independent detections. Chance of interference explaining all observations. Negligible, but still no modulation. Just carrier. Like someone transmitting, "We are here," without saying anything else. Or like radar. Active illumination of object. But by what? Who? January 5th. Dr. Avi Loeb at Harvard published opinion piece. The transmission from 3I Atlas. Evidence grows for technological origin. Arguing objects' properties, impossible spectroscopy, infrared excess, polarization anomaly, perihelion activation, radio emission, cumulatively suggested technology, not natural object, probe from another civilization, sent to explore galaxy, now passing through solar system, announcing presence, the mainstream community divided. Some, this is premature. Natural explanations haven't been exhausted. Radio emission could be Maser effect. Natural amplification of radio waves through stimulated emission. Happens in molecular clouds, rare but natural. Others, multiple independent anomalies. Each strange, together, pattern suggests non-natural. Need to consider technological hypothesis seriously. SETI protocols activated. International coordination. Alert all observatories. Maximum coverage. All wavelengths. Look for additional signals. Patterns, modulation, anything suggesting message or intentionality. NASA Administrator held press conference, January 6th. We're aware of radio emission from 3I Atlas, monitoring closely, investigating all possibilities, natural and otherwise, making no premature conclusions, following data wherever it leads. If this is first contact scenario, we'll know. If it's natural phenomenon, we'll understand that too. Science in action. Stay tuned, carefully worded. Not dismissing alien hypothesis. Not endorsing it. Maximum uncertainty. Maximum caution. Because announcing "we found aliens" then retracting would destroy credibility. Better to be slow and correct than fast and wrong. January 15th, 2026. SpaceX Icarus mission entered final preparations. Launch date May 15th, 4 months away. Spacecraft designed. Hardware manufactured. Systems integrated. Testing underway. On schedule. Barely. But on schedule. Mission profile refined. Launch Starship HLS variant to LEO refuel using 7 tanker flights over 5 days, trans 3I injection burn. Delta V 14.2 kilometers coast 24 days to intercept flyby at 12 km/s relative velocity, too fast to stop. Release impactor probe. Hits at 8 km/s, creates ejecta plume main spacecraft flies through plume. Collect samples with aerogel secondary capture. Deploy nets. Catch dust particles post-flyby, return trajectory. Burn coast 18 months back to Earth entry. Dragon capsule with samples landing. December 15th, 2027 Dr. Lindy Elkins Tanton at Arizona State University. Mission Principal Investigator. This is most ambitious sample return mission ever attempted. Intercept velocity is extreme. Sample collection is challenging. But if successful, we'll have interstellar material in laboratory. Can analyze with mass spectrometry, electron microscopy, X-ray crystallography. Every technique available. Will identify mystery elements, determine composition, solve spectroscopic puzzle. Maybe answer whether this is natural object or technological artifact. Payload manifest. High-resolution cameras. Document object. 10 cm resolution spectrometers. UV visible NIR. Confirm spectral features. Magnetometer. Measure magnetic field. Mass spectrometer. In situ composition analysis of ejecta. Sample collection system. Aerogel panels. 1 square meter area. Sample return capsule. 100 grams capacity. The mission would answer definitively. Natural or artificial? Known chemistry or exotic? One-time opportunity. If mission failed, mystery would persist. Object would escape. Gone forever. Never knowable, but mission had 60% success probability. SpaceX estimate. Conservative. Many things could fail. Launch delays. Refueling problems. Navigation errors. Sample collection might yield nothing if timing wrong. Return might fail. Capsule might burn up, 40% chance of failure, but 60% chance of success. Better odds than doing nothing. Public interest was enormous. Media coverage daily. SpaceX to chase interstellar visitor. Possible alien probe to be sampled. Mystery objects' secrets may be revealed. Speculation rampant. Excitement high. Fear present. What if it was alien? What if we provoked response? What if sampling damaged it? What if? January 30th, Elon Musk press conference. Icarus mission is go. We launch May 15th, 4 months. Engineering team working 24/7. This is humanity's shot. First time we can touch material from another star system. First time we might encounter technology not made by humans. Historic moment. We're ready. We're doing this. February 2026. Object continued evolving. Radio emission strengthened. Now 1.2 Janskis. Brightness invisible increased 30%. Infrared excess now 100% above expected. Object was activating, warming up, responding to solar proximity, or to something else. Internal process. Unknown trigger. Dr. Michelle Bannister watched data accumulate. All the observations. All the impossibilities. Spectral lines at wrong wavelengths. Infrared excess. Polarization anomaly. Radio transmission. Perihelion activation. Pattern was undeniable. This wasn't random natural object. This was something special. Something unprecedented. Either, she concluded. 3I Atlas is natural object with chemistry so exotic it defies all our understanding. Formed in environment so different from anything we know that its properties seem impossible. Or it's not natural. It's manufactured. Technology from another civilization. Sent to explore, transmitting, documenting its journey. Maybe recording us. Maybe reporting back. Both possibilities are revolutionary. Both challenge what we think we know. Both require rethinking our place in universe. Natural explanation means universe is more chemically diverse than we imagined. Artificial explanation means we're not alone. Either way, 3I Atlas is most important astronomical discovery of the century. And we have 3 months until samples return. 3 months until we know? Until uncertainty becomes knowledge. Until speculation becomes fact. March 2026. 3I Atlas receding from Sun. Now 2.1 AU. Brightness fading. Radio emission weakening. Infrared excess declining. Object returning to dormant state. Or finishing its mission. Or conserving energy for long journey ahead. Trajectory confirmed. Hyperbolic. Escape velocity achieved. Will leave solar system. Exit through Oort cloud. Journey into interstellar space. Direction toward constellation Lyra. Not back to Vega. Different trajectory. Different destination. Will take 50,000 years to reach next stellar system. HD 217014, K-type star. 27 light-years away. Will 3I Atlas arrive there? Function there? Transmit there? Explore that system as it explored ours? Icarus mission proceeded. Launch date, May 15th, 2026. T-minus 75 days. Hardware complete. Testing finished. Spacecraft ready. Waiting for launch window. waiting for object to reach optimal intercept geometry, waiting for humanity's first touch of interstellar material, scientific community remained divided. Conferences held, papers published, debates raged. Natural versus artificial, chemistry versus technology, known physics versus new physics. No consensus, no agreement, just data. Mountains of data, all pointing to something unprecedented, something revolutionary, something that didn't fit. Dr. Avi Loeb led artificial hypothesis faction, cumulative evidence overwhelming, multiple independent anomalies, all unusual, together suggesting design, purpose, technology. Occam's razor, simpler to accept technological explanation than invoke unknown chemistry, unknown physics, unknown everything to preserve natural explanation. Dr. Alan Fitzsimmons led natural exotic chemistry faction. Universe is vast, chemistry is diverse. We've sampled tiny fraction of possible materials. 3I Atlas formed in different environment, different stellar conditions, different planetary processes, unusual but natural. Jumping to aliens is premature, unscientific, damages credibility. But everyone agreed. Samples would decide. Laboratory analysis would answer. Mass spectrometry would identify mystery elements, or confirm known elements in exotic compounds. Structural analysis would show natural crystallography, or manufactured structure. Truth would emerge December 2027, 20 months away. Public fascination sustained. When will we know? Is it aliens? What if it's dangerous? Should we be contacting it? Questions without answers, speculation without limits, fear and excitement in equal measure. Governments prepared quietly. Protocols for contact scenario. United Nations Office for Outer Space Affairs activated contact committee. Established by treaty. Never used, now potentially necessary. What if Icarus returned not just samples, but message? Information? Technology? Instructions? Plans drafted. Containment facilities for samples. Level 4 biosafety. Prevent contamination. Prevent cross-contamination. Analyze safely. No risk to Earth biosphere. Even if samples contained exotic chemistry, or microorganisms, or nanomachines, or anything, communication protocols discussed. If object was technological and responsive, should we try communicating? Send message? Radio transmission? Laser signal? Or observe silently? Not reveal ourselves? Not advertise presence? Opinion divided. Some announce ourselves. Show we're intelligent, peaceful, curious. Others stay silent. Don't attract attention. We don't know intentions. Could be dangerous, SETI continued monitoring. Radio emission from 3I Atlas weakened as object receded but remained detectable. Still at hydrogen line frequency. Still narrow band. Still unexplained by natural processes. Maser hypothesis tested. Calculations showed insufficient pumping mechanism. Natural maser required energy source. Molecular clouds. Star formation regions. 3I Atlas had neither. Emission shouldn't exist naturally. But did April 2026, final checks before launch. Icarus spacecraft mated to Starship booster. Rollout to launch pad. Fueling operations. Countdown clock started. T-minus 30 days. World watched. Cameras on SpaceX. Cameras on object. Cameras everywhere. History being made, one way or another. Natural or artificial. Chemistry or technology. Truth approaching, Dr. Elkins Tanton gave final pre-launch interview. Whatever we find, we'll learn something fundamental. About universe. About chemistry. About life. About technology. About our place in cosmos. 3I Atlas came from the stars. Brought mysteries. Brought questions. Now we're going to get answers. May 15th, then 581 days. Then samples in hand. Then knowledge. I've been planetary scientist 30 years. This is culmination. Peak. Most important moment. Not just for me, for humanity. We're reaching out. Touching infinity. Learning secrets. Beginning journey to understanding we're not alone in cosmos, one way or another. May 15th, 2026. Launch day. Perfect weather. Starship on pad. Fueled. Ready. Countdown. T-minus 10 minutes. World watching. Billions of eyes. Waiting for fire. Waiting for thunder. Waiting for humanity to reach toward the impossible visitor. Toward the object that broke physics. Toward the answer that might change everything. The countdown reached 0. Engines ignited. Starship rose. Perfect launch. Perfect trajectory. En route to 3i Atlas. En route to truth. En route to knowledge that would define the 21st century. And days until samples returned. 581 days until mysteries solved. 581 days until humanity learned whether it was chemically ignorant or cosmically lonely. Either answer would revolutionize civilization. Either answer would reshape humanity's understanding of its place in universe. The wait began. The longest wait. The most important wait. For the first photons that reached Earth were wrong. And soon, very soon, we would know why. Sleep now knowing that above you, beyond Mars, beyond the asteroid belt, an object from another star system is traveling through our solar system, carrying impossible light, broadcasting mysterious signals, defying every law of physics we understand. In 581 days, samples return. In 581 days, we know. In 581 days, everything changes. Either we discover chemistry beyond our imagination, or we discover we're not alone. Either possibility rewrites human history. For now, uncertainty. Tomorrow, mission continues. December 2027. Truth arrives. The impossible visitor's secrets will be ours. Sweet dreams, citizen of solar system hosting interstellar guest. The stars sent us a message. We're about to read it. Subscribe, CTE. If this journey through the most mysterious object ever detected made you realize how little we know about what's traveling between the stars, hit subscribe. Every week we explore cosmic mysteries that challenge everything we think we know. From impossible visitors to signals we can't explain to missions that might change history. The universe is stranger than we imagine, and we're finally starting to see how strange. Don't miss what Icarus brings back in December 2027.